Okay, so bisect means to cut in half. Perpendicular means 90 degrees. Put the two words together. We're talking about the line that's both perpendicular and cutting the line in half. Okay, that's what we're going to be looking at within triangles today. So let's start by drawing a triangle. So if I were to draw what we call the perpendicular bisector, it would be a line, bless you, that is 90 degrees and cutting it in half. So what does that make this point D in the middle? It makes the angle 90, but it also makes the point a midpoint. Okay, so we have both perpendicular and bisector. And so when we have a perpendicular bisector, there's a theorem that we can use that helps us do some things. So if we know we have a perpendicular bisector, so I'm going to say AD, so I'm going to call this A. If AD is perpendicular, let's call this BC, to BC, and AD is, or not AD, BD, and BD is congruent to DC. So all this is saying is if we have a line that's both perpendicular and bisecting, then AB is congruent to AC. So what that means is that these two sides will also be congruent. That's what this theorem says, is that if you have a perpendicular bisector, that the two sides of your triangle are going to also be congruent. Or those two lengths are going to be congruent. Okay, and it also works the other way. So we also have what's called the converse. So do you remember what converse was from the last unit when we talked about it? So this up here was called the perpendicular bisector theorem. And then we have the converse perpendicular bisector theorem. This one says the same thing, just backwards. So it's saying if you have a picture with a line down the middle and you know these two sides are congruent. So what kind of triangle is that when two sides like that are congruent? Isosceles. So this is something that works with isosceles triangles really well. So if you know that you have a line going through the middle or going through your angle, your vertex angle, and these two sides are congruent, then you know you have a perpendicular bisector. So it's just the theorem but backwards. So if you know so if AB is congruent to AC, and CD is perpendicular, no, BD, sorry, I have my letters off. So I'm just going to relabel this the same as above. So if AB is congruent to AC and AD is perpendicular to BC, bless you, then BD is congruent to CD. In other words, D is a midpoint. So how do we actually use this kind of stuff? What's the whole point of it? Well, we're going to still be finding information about triangles. So in our first example here, we're going to use these two theorems to find Mn. So let's see. I'm going to draw my triangle. M, O, N, P, so you might be given a picture something like this. And you're asked to find the length of Mn. Okay, this is a theorem that allows us to set up an equation. That's the whole point of this theorem. So when you look at your picture, you should be looking to see, do you have a perpendicular bisector? Yes or no? So in this one we do, because that says it's 90 and these are equal. That means this is a perpendicular bisector. So then what can we say about these two lengths on either side? They're equal to each other. So we can set up that equation so we can solve for x. So we can subtract 4x to both sides. Bless you, add 7 to both sides. And we get that x is equal to 13. Were we asked to find x? No, we're asked to find Mn. So I'm going to go back to my expression for Mn and plug 13 in. So we'll get 52 plus 19, Mn is 71. Okay, so this is how we use this theorem, is to be able to look at a picture and decide, do we have what we need? So do we have a perpendicular bisector? And if we do have a perpendicular bisector, we can say those two sides are congruent. Okay. Another way we can use this same theorem is for one that looks like this, where we're going to find JL. So we're still finding a side length. So we're given something that looks like this. So again, we're going to use one of our theorems to help us set up some sort of equation. So what do we know about our picture?
It's a perpendicular bisector.
Okay, we actually don't know for sure it's a perpendicular bisector. All we know is that it's perpendicular. Our markings aren't on this side. But we do have markings on these two sides. So this one is actually using the converse, because we know that these two sides are congruent and that we have a 90 degree, which means that we do now know it is a midpoint. So this one's going backwards with the converse, whereas this one used the perpendicular bisector theorem. Okay, do you guys see the difference? It all has to just do with what you know as to which one you're using, but you're right, they are equal, and we do now have a perpendicular bisector because of the converse. So we can set them equal to one another. And then we solve for x. So I'm going to get my x's together, get my constants together. So we have 20 equals 2x. So x would equal 10. But what did it ask us to find? The length of JL. So I need to find this whole length. So we're going to add the two lengths together. So 3 times 10 plus 4 plus 5 times 10 minus 16. That's going to be our entire length of JL. So 3 times 10 is 30. 5 times 10 is 50. So I'm using my order of operations here. Multiplying, whoops, JL, not JK. Multiply and then add the numbers together. So after we add these all together, we end up with 68. Okay, any questions so far, Chase?
Right, since JK and KL are congruent, which makes JM and ML congruent, can't you just find the answer to one of the equations and multiply by 2?
That's another way to do it, yep. All right. So let's see. Next part, we're going to do a couple more. So our next one, this is example number 3. We're told if RT bisects SU, find each measure. So I'll draw you guys the picture here in just a second. Okay, so this would be our picture that's given, and we're going to answer, or we're going to find these following lengths. All right, so when we look at this, what do we know about the word bisect? Chase? Oh, I forgot to mark V. V is this point in the middle. Okay, so what does the word bisect mean? Cuts it in half. Okay, so if RT cuts SU in half, what can we say? So this line cuts this one in half. So VU is 5. Denuna? SV is also 5. I also forgot to draw the 90 degree here. Okay, so we know that those two are congruent. Now, I forgot to draw the little 90 in there. That should be there. So what does that make RT? If it's perpendicular and it cuts it in half.
10.
It does make the whole length 10, yes, so SU would be 10. But now we need to try to figure out ST. What is it? It is 23 because RT is now a perpendicular and a bisector, which would make these two segments the same. Now it also would make these two the same, RS and RU. So it would make both of those the same, just we only needed to find information on the one side. Okay, next one.
Wait, the 23, where'd that come from?
Okay, so this was given to us.
Okay.
This 23 was given. We are using the fact that it's a perpendicular bisector to be able to also say that one's 23. Okay, so in our next one, we're again trying to utilize what we know about what we see in this picture. So this one we're just going to solve for x. So to solve for x, what do we know about the picture? We know they're equal to each other because we have a perpendicular bisector. So we can set 24x minus 19 equal to 16x plus 13. Get the x's together. Get the 19 over with the 13. And we get that x is equal to 4. Okay, how are we doing so far with this theorem? It's really just about recognizing that you have a perpendicular bisector and what does that mean equals each other. That's really all there is to it, all there is to this theorem. Okay, this next one we're going to do, it's kind of like number 3, where we're going to draw a picture and we're going to find a bunch of stuff about it. So to start our picture off, I'm going to draw a line. I'm going to draw a triangle on top of that line. And I'm going to draw this line. Say it's perpendicular. I'm going to call that Q, P, 5y minus 31, 2y plus 5, R, T. And then down here, I'm going to draw another triangle on the bottom of it. I'm going to call this S, or x plus 4, 7x minus 17. Okay, and then this one is 6x minus 2y.
Can you scoot it
I
up?
will scoot it up. Thank you for letting me know that you could not see it. Okay. Alright, so this is everything we're going to find for this one problem. And I'm going to tell you that QT is the perpendicular bisector of PR. So I'm going to start this one by looking at what does QT, this line here, what does it mean to be a perpendicular bisector of PR? What can we mark on our picture as equal, knowing that this is the perpendicular bisector of this line? Can anyone tell me one thing we know is equal? Chase? We know that these two are congruent, because by definition of bisector. What else do we know is congruent? We also now know that PQ and RQ are congruent. Is there anything else that we know? Chase?
SR is congruent to SP.
We actually don't know that. Because is there a line that goes perpendicular here to say that this is also perpendicular? So then why do you think we can say that? Yeah, it's not quite one that we can say just because we don't know. All we know is that T is in the middle, but we don't know for sure that the line connecting S to the middle is a perpendicular. So we can't quite say that, but we do, I think, have enough information to be able to find X and Y. So let's start by finding something. Let's see which one. So we know 5y minus 31 will equal 2y plus 5. So that equation lets us solve for y. So let's see, we subtract 2y, add 31. So we'll get 3y equals 36. So y is equal to 12. Okay. Then we also know that these two have to equal each other. Let's see, how can we use that to help us? Well, we can find the length of PQ now if we really wanted to. So let's see, PQ is, plug in 12, 5 times 12 minus 31. So 5 times 12 minus 31 would give us 29. 2y, so 2 times 12 plus 5, 24 plus 5, 29. Alright, I think the person who wrote this example did not give us enough information. Okay, so let's go ahead and assume, so we're going to do the big A word, let's assume that S is also on the perpendicular bisector, because otherwise we won't be able to do this whole problem. So I'm going to make a note of that for the person who wrote this one. So if we assume that S is also on this perpendicular bisector, now we can say that 4x and plus 4 is equal to 7x minus 17. Move the 4x over, and then add the 17 over. So x would equal 7. Which then would let us find PS. So 4 times 7 is 28. 28 plus 4 is 32, which means SR would also equal 32. And now we have enough information to find PT and PR, or sorry, we already found PR, oh no. We can find PT by plugging 6x minus 2y. So 6 times 7 minus 2 times 12, we get 18. Double that to get the whole length of 36. Okay, so, sorry, this one was written by somebody else that I was using, and it never said S was on the perpendicular bisector, so we'll make that assumption. Rosemary?
Did you guys solve the X
We could have, it's just I was going off of what this example says, and until we know S is on the perpendicular bisector, we can't solve for X. So once we know that, then yes, we could have done X and Y first, and then just use those to plug in. So I made a note to let the person who wrote this one know that they need to add that in there. All right, so I have one more thing I want to go over with you, I believe. And that is, what do we call a point? So draw a really big triangle, because we're going to be drawing inside this triangle. Okay, I'm going to call it TUV. If we were to draw, or find, sorry, if we were to find the midpoint of each side, so here's my midpoint for each side. And I were to draw the perpendicular bisector of each side. So I'm going to draw the perpendicular bisector. So I'm going to draw, and I'm going to estimate these just to save time instead of constructing them. If I were to draw all three perpendicular bisectors, they would, and I were to continue them until they met up. They all will meet at a point. So perpendicular bisectors all meet at a certain point in the middle. This will always happen. Whenever you draw in a triangle all three perpendicular bisectors, so when you draw all three of these, they meet at a point. That point has a special name. You have to know what that name is. Okay, so all three that meet at a certain point, that certain point is called a circumcenter. This is the words you need to know. And because you're going to have on your test as well as on your quiz kind of a matching. You're going to have, what do the perpendiculars meet at? The circumcenter. So it's a vocabulary term you're going to need to know. We're going to be learning a total of 4 points in this chapter. This is the first one. All of these points are called points of concurrency. So do you guys know what the word concurrency means? Have you ever heard of it before? Do you know what concurrent means? Happening at the same time, together. So like when events are happening at the same time, they're called concurrent events. And so what we call these are points of concurrency because they're points where multiple lines all meet at once. So like if you've ever ridden the BART in San Francisco, you know those stations where all of them meet and you can transfer, or the subway in New York, or any of those. Anytime you go and you on a public transportation and you're looking at where do all the things meet, those are called points of concurrency for a subway system or for a BART system, because that's where multiple trains meet and you can switch trains. Okay, so you're going to need to know that three perpendicular bisectors create a circumcenter, and one of the things that's interesting about this circumcenter is that from this point, if you were to draw lines to each of the vertices, I'm going to make them solid, not dotted. So if I were to draw these 3 lines from the circumcenter to the vertices, all 3 of these lines will be the same length. And that's something that's special about the circumcenter, is that the distance from the circumcenter to the vertices are congruent. Okay, so on your homework tonight, you're mostly just going to be looking at identifying it, or if you see something like this where it says, if this is 10, then what do you know about these other two segments? They're all 10. That might be a question that you have.